Okay, chapter 26, practice problem number 2. And for this exercise, we are to calculate the net present value on this investment here. So it looks like a company is considering to invest in a machine that's going to cost them $150,000. So that will be the initial investment. From this investment, they have came up with some cash flows that could possibly be generated from this investment. And so we can see here that from years 1 through 5, that we have our unequal cash flows that they are, planning to generate from this investment. So this is all hypothetical. This is a future goal. Okay, so from this investment here, the company does require a ROI, so a return on the investments of 10%. So for letter A, we have to compute the net present value of this investment. And letter B, should the machinery be purchased? So before we get started with tackling letter A, I want to talk a little bit about the time value of money, because it is very important to note or to consider the time value of money whenever you do. I want to say make an investment on something that you are trying to generate money in the future. So when it comes to the time value of money, you do have to understand that a dollar today, so if you have a dollar bill right in front of you, that same dollar tomorrow is going to be worth less. So if you go into the next day, that dollar is going to be worth, now this is just for example, just illustrating the time value of money, that dollar is going to be worth 99 cents. Even though, yes, you're holding up a dollar, but since you have the dollar in your hand today, yes, it's a dollar right now, but the next day it's going to be worth 99 cents. And that's taking into consideration the time value of money. This is why it is suggested that you take your money, whatever money you have on hand, put it in an account that is interest bearing, that's actually generating interest. And the interest could be 0.000001 or 2 or 3. That's fine as long as it's generating some type of interest, because as time goes on, the I want to say the money that you currently have on hand is going to be worth less in the future. That's the time value of money. So when it comes to us actually calculating the net present value on cash flows, we're going to be discounting. That's what the 10% return rate on here, return on investment. We're going to be discounting the cash flows for each year. And you're going to notice that, for example, for year 1, we have $10,000. You're going to notice that the net present value is going to be lower than $10,000. That's because we're year 1, what we have 12 months. So $10,000 is what we think that in year 1, that's what is going to be generated in cash. But you have to take the whole year into consideration. So from January 1st, 2nd, 3rd, 4th, and then so on, and then move into February and so on. That value there, present value, every single day is going to be reduced. And it's for 1 year. Year 2 is going to be reduced even further. Year 3, same thing. Year 4, same thing. And year 5 as well. So that's how the time value of money works. And so in this case, we are going to be using the present value of a dollar table, because it's going to discount that cash flow here that is actually displayed for years 1 all the way to year 5. Okay, so let's go ahead and tackle this. For letter A, we are to compute the net present value of this investment. Okay, so we're going to be doing this for each year. So for year 1, we're provided with $10,000. Okay, this $10,000 will need to be discounted. So that lets you know that, I want to say, by the end of the year, this $10,000 is not going to be worth $10,000 right now. What you see right now, it's going to have to be discounted. And that's what this 10% here, return on investment here, that's what that rate is for. It's an actual discount rate. So we're going to take, well, they let us know it's 10%. So let me just erase this so you can see it better. 10%. Okay. And we have 5 years in total. So what we're going to do is first go to year 1, because this is, they're projecting that they're going to generate $10,000 in cash. And for year one, we're going to go to the present value table of $1, and we're going to go to, well, year one it's equivalent to period one. And then since this is a 10% return on investments, that's what they require. We're going to go to all the way to 10%. And we're going to see that 10% for the first year, the present value factor that we're going to have to actually apply to the $10,000 is going to be 0.9091. So this $10,000, we're going to multiply it by 0.9091. And that's going to give us $9,091. Okay, so right off the bat, before we even move on to year two, we see that year one, that $10,000, the present value of that $10,000 is going to be $9,091. Okay, now we move on to year two. Year two, we have 25,000. Okay, so now we have to take into consideration the second period because that's year two. So we go down here to the present value of one chart and we find the period two. That's for year two. Go back to 10%. We have the factor here of 0.8264, which is going to be applied to this $25,000 that is projected to be generated in cash. And we're going to multiply that 25,000 by 0.8264. Okay, that's going to give us $20,660. Okay, so the future value is 25,000, but the present value of that $25,000 is $20,660. So the present value is a true value. It's more realistic because, well, when year two comes and then it goes from January all the way to December, well, that $25,000 is not going to be $25,000 by the end of the year. Instead, it's going to be $20,660. That's the value. That's what it's going to be worth. Now we move on to year three. Year three, we have 50,000. And from the present value table, we're going to go to period three and then go to 10% here, and that's going to be 0.7513. So we're going to apply the 0.7513 to 50,000. And that's going to be $37,565. Okay, big difference here. So as you can see, as the years go on, the factors are going to be lower. Now we go to year four, take 37,500, multiply it by, well, go to the table first. We're in period four, and we're going to multiply it by 0.6830. Okay, that's going to give us $25,613. I believe it's 25,612 point something, but rounding it to the nearest whole dollar, that's going to give us this amount, $25,613. Then we go to year five. Year five is going to be 100,000. Some big money there. So we go to period five, and the factor is going to be 0.6209. There we go, 6209. And then that's going to come out to be $62,090. Okay. So we see the difference here. And again, these are our future values. This is what the company is projecting to generating cash flows from this investment. But they have to convert this projection into what it actually is worth presently, currently. So they have to, have a realistic projection on what that actually is worth. And this is the realistic projections here. This is your net present value here. So if we do the math and add all of the net cash flows, annual cash flows up together, this going to come out to be $155,019. Okay, so this is our NPV, our net present value on the future net annual cash flows. So that's letter A. Now for letter B, we are to see if the company should purchase the machine. And so in this case, well, the company is considering investing $150,000 in the machine. So we're going to take 150,000. Okay, this is going to be our investment. Okay, I'm going to put on here letter B. So this is going to be our investment here. And so since our net present value is greater than the investment here, and this comes out to be $5,019. This is a positive here. Yes, the answer is yes. They should purchase the machine because the net present value is greater than the cost of the machine, which is the initial investment of $150,000.